China joins supersonic race with plans for Concorde beating jet, the C949 project. On March 30, 2025, China officially entered the race to develop a new supersonic passenger jet, the C949, marking a significant moment in the revival of global interest in supersonic air travel. This announcement comes as various countries and companies explore advanced aviation technologies following the retirement of the iconic Concorde in 2003. The C949 is designed to surpass Concorde in speed, range and noise reduction, aiming to redefine the standards of commercial air travel. Key features of the C949. The C949 jet is engineered to achieve a flight speed of 1.6 times the speed of sound, Mach 1.6, with an impressive operational range of approximately 11,000 kilometers (6,800 miles). This range is significantly greater than Concorde's maximum range of 4,500 miles. The aircraft's design includes innovative features aimed at minimizing sonic boom noise, with expected sonic booms measuring around 83.9 decibels, compared to Concorde's 105 decibels. One of the critical advancements in the C949's design is its reverse-camber fuselage, which is crafted to mitigate the shockwaves that create sonic booms. This design innovation seeks to address the noise complaints that plagued Concorde and hindered its operational viability over land. The C949 is intended to accommodate 168 passengers, surpassing Concorde's maximum capacity of 128. However, it will fly at a lower top speed than Concorde, which reached Mach 2.2, about 2,154 km per hour or 1,338 miles per hour, while the C949's top speed will be limited to Mach 1.6. Competitive landscape. China's entry into the supersonic aircraft market coincides with ongoing efforts from several American companies and organizations. Notably, Boom Supersonic, based in Denver, has successfully conducted test flights of its XB-1 prototype, achieving speeds of 850 miles per hour. Their upcoming full-sized Overture jet aims to reach speeds of Mach 1.7 but has a maximum range of only 4,888 miles. Similarly, Spike Aerospace, based in Massachusetts, is developing the S512, which targets Mach 1.6 and boasts a longer range of 7,100 miles. The competitive dynamics of this aerospace race are heightened by the involvement of NASA and Lockheed Martin, who are working on the X-59, a project aimed at creating a quieter supersonic aircraft. Timeline of events. The development of the C949 and the renewed interest in supersonic travel can be traced back through key historical milestones. 1. 2003, the Concorde is retired from service due to economic challenges and safety concerns following a fatal crash in 2000. 2. 2008, the Chinese government establishes the Commercial Aircraft Corporation of China (COMAC) to enhance domestic aircraft manufacturing capabilities. 3. March 2025, COMAC announces the C949 project in an academic paper, detailing its design innovations and performance objectives. Concerns and implications. China's ambitions in supersonic technology raise several concerns regarding the potential dual use of such advancements for military applications. COMAC has faced U.S. sanctions due to its connections with the People's Liberation Army. As nations increasingly recognize the strategic importance of aviation technology, the C949 project emerges amid a complex geopolitical landscape. Common points across sources. Media coverage highlights several key aspects of the C949 project. The aircraft's speed, range, and reduced noise levels are significant improvements over the Concorde. The competitive nature of the aerospace industry is emphasized, with American companies actively pursuing similar supersonic developments. Regulatory challenges related to noise concerns remain a prominent theme which the C949 aims to address. Differences between sources. While the sources agree on the C949's technological advancements, they differ in emphasis. Some sources highlight the potential military implications of China's advancements in aviation technology. Others focus more on the competitive dynamics and specific innovations of U.S. companies. A few provide technical insights into the C949's aerodynamic features compared to more general coverage in other reports. Conclusion. In summary, China's C949 project represents a pivotal step in the resurgence of supersonic commercial air travel, poised to compete with American initiatives while addressing past noise and environmental concerns. As the global aerospace landscape evolves, the pursuit of faster, quieter, and more efficient air travel technologies continues to shape the future of aviation. With key players like China, the US, and various companies racing to develop supersonic jets, the next decade will be crucial in determining the future of air travel and competition in the skies. In the context of China entering the supersonic passenger jet development race with the C949, several counterintuitive points emerge from the information provided. 1. Quiet supersonic travel versus environmental concerns. While the C949 aims to reduce sonic boom noise significantly, creating a quieter supersonic jet may paradoxically lead to increased regulatory scrutiny rather than easing it. Traditionally, supersonic flights over land have been restricted due to noise pollution, but even with decreased noise levels, the environmental impacts of supersonic travel, such as fuel consumption and carbon emissions, remain contentious. This could result in more stringent regulations. Despite the advancements in noise reduction technology. 2. Military implications of commercial technology. The advancements in supersonic technology for passenger jets could unintentionally bolster military capabilities. The perception that a commercial aircraft could double as a military asset complicates the narrative around civilian aerospace innovations. While many view the development of a supersonic passenger jet as a purely commercial endeavor, there are underlying dual-use concerns where technology developed for civilian applications could be adapted for military purposes. 3. Capacity and speed trade-offs. The C949 is designed to accommodate more passengers, 168 than the Concorde 128, but with a lower maximum speed, Mach 1.6, compared to Concorde's Mach 2.2. This may seem counterintuitive, as one would expect advancements in technology to yield both higher speeds and increased capacity. However, the focus on quieter operations and longer ranges appears to take precedence over sheer speed, suggesting a shift in consumer priorities towards comfort and efficiency rather than pure speed. For a geopolitical strain versus collaborative opportunities. While the announcement of the C949 heightens competition between China and the United States in aerospace technology, it also opens avenues for potential collaboration in aviation standards and noise regulations. The shared challenges of developing supersonic travel could lead to cooperative frameworks despite the prevailing geopolitical tensions. This highlights the complexity of international relations, where competition in technology could foster collaboration in regulatory environments. 5. Public perception of supersonic travel. The renewed interest in supersonic travel, despite its historical baggage of safety and environmental concerns, indicates a counterintuitive shift in public sentiment. The excitement surrounding new technologies may overshadow past failures like the Concorde's retirement, suggesting that nostalgia and innovation can coexist in shaping consumer expectations and market viability. 6. Investment in aerospace versus economic viability. The push for supersonic jets like the C949 occurs amid significant economic uncertainties and potential downturns in the aviation industry. The substantial investments required for developing such technology may seem irrational, especially when many airlines are still recovering from the impacts of the COVID-19 pandemic. This raises questions about the economic viability of such projects, suggesting that the allure of technological advancement may be prioritized over immediate financial returns. These counterintuitive points reflect the complexities and contradictions within the development of the C949 and the broader context of supersonic air travel. Challenging traditional notions of progress in aviation technology. China's entry into the supersonic passenger jet market with the C949 is significant for several reasons that often go unnoticed amid the excitement surrounding technological advancements. Here are key elements of the report that merit deeper consideration. 1. Technological innovations, reverse-camber design. The C949's innovative reverse-camber fuselage design is pivotal in reducing sonic boom intensity from 105 decibels Concorde to around 83.9 decibels. This change is not merely a technical improvement, it represents a potential paradigm shift for supersonic travel. The ability to mitigate sonic booms could allow the C949 to operate overland routes which were previously restricted due to noise complaints. This opens new markets for airlines and could redefine air travel patterns, increasing demand for supersonic flights. Significance: the reverse-camber design could lead to regulatory changes that facilitate wider acceptance of supersonic travel, making it more commercially viable. This innovation highlights China's capacity for engineering breakthroughs in the aerospace sector. 2. Geopolitical implications. China's ambitions in supersonic technology are intertwined with global geopolitics, particularly regarding its military capabilities. COMAC's links to the People's Liberation Army raise concerns about the dual-use nature of supersonic technology. As countries like the US and China engage in a technological arms race, advancements in civilian aerospace can have significant military applications such as faster military transport or reconnaissance capabilities. Significance: this geopolitical angle is often overshadowed by discussions of commercial aviation. Understanding the military implications helps contextualize the urgency and seriousness with which nations approach advancements in aerospace technology. 3. The competitive landscape and market dynamics. While the report emphasizes the competitive nature of the aerospace industry, it is crucial to note how China's involvement could shift market dynamics. U.S. companies like Boom Supersonic and Spike Aerospace are also developing supersonic jets, but the entry of a state-backed entity like COMAC introduces a different level of competition. The Chinese government can leverage substantial resources and support, potentially allowing COMAC to outpace private enterprises in innovation and production speed. Significance: the emergence of state-backed aerospace projects can lead to market disruptions. The potential for significant government funding and support can create an uneven playing field, impacting global supply chains and competitive strategies within the aerospace sector. 4. Environmental considerations and regulatory challenges. The C949's reduced sonic boom is a step towards addressing environmental concerns related to supersonic travel. However, the aircraft's overall environmental impact, especially regarding fuel consumption and emissions, remains a point of contention. The original Concorde was criticized for its high fuel use and carbon footprint, and while the C949 aims to be quieter, it is imperative to assess its ecological implications thoroughly. Significance: environmental regulations are likely to shape the future of aviation technology. Overlooking the full environmental impact of new aircraft could lead to backlash from regulators and the public, potentially stalling progress in supersonic travel. 5. Historical context of supersonic travel. The revival of interest in supersonic travel is not just about technological capability, it carries historical significance. The Concorde was celebrated for its engineering marvel but was ultimately retired due to economic pressures and safety concerns. The C949 represents a second chance for supersonic travel, where past mistakes can inform future designs and operational strategies. Significance: this historical context is vital as it informs current expectations and risk assessments regarding the viability of new supersonic jets. Ignoring the lessons of the past could lead to repeating mistakes, particularly in pricing, safety, and public perception. 6. Timeline and strategic positioning. The goal of having the C949 operational by 2049, coinciding with the centenary of the People's Republic of China, reflects strategic long-term planning. This timeline not only positions China as a leader in aerospace technology but also aligns with national pride and economic goals. Significance: long-term planning and technology development signals a commitment to becoming a dominant player in the global aerospace market. This ambition may spur further investments and innovations influencing the competitive landscape for decades. 7. Public perception and market acceptance. Public acceptance of supersonic travel hinges on perceptions of safety, environmental impact, and economic feasibility. The C949's quieter operation is a step toward addressing noise complaints that plague the Concorde, but public skepticism may still linger due to historical failures. Significance: understanding public sentiment is crucial for the commercial success of the C949. Companies must engage with potential customers, stakeholders, and regulatory bodies to foster a favorable environment for the return of supersonic travel. Conclusion: the C949 is not merely a technological advancement, it is a complex interplay of engineering, geopolitics, environmental concerns, and market dynamics. Each of these elements carries weight in the broader narrative of aviation's future. By focusing on these often overlooked aspects, stakeholders can better navigate the challenges and opportunities that lie ahead in the resurgence of supersonic travel. The significance of the C949 extends beyond its specifications. It encapsulates the aspirations, fears, and complexities of a rapidly changing world. The announcement of China's C949 supersonic jet marks a significant milestone in the resurgence of supersonic air travel, particularly in light of its competition with American aerospace companies. Here are the 4 most valuable points for in-depth analysis and discussion. 1. Technological advancements and design innovations. The C949 is designed not only to exceed the performance metrics of the Concorde but also to address historical criticisms associated with supersonic flight, particularly concerning noise pollution. The aircraft is set to operate at Mach 1.6 with a range of approximately 11,000 kilometers, 6,800 miles, which is significantly more than Concorde's maximum range. Reverse-camber fuselage design. This innovative design is aimed at reducing sonic booms to a perceived level of 83.9 decibels. This is a crucial advancement because it addresses regulatory barriers that have historically limited supersonic flights over land due to noise complaints, by potentially allowing overland flights. The C949 could revolutionize travel routes and times. Passenger capacity and comfort. The C949 is expected to accommodate 168 passengers, surpassing Concorde's capacity of 128. This increase in passenger capacity, combined with advancements in cabin comfort and technology, could make supersonic travel more appealing and economically viable. 2. Competitive landscape and global implications. China's entry into the supersonic race intensifies competition in the aerospace sector, particularly with American firms like Boom Supersonic and Spike Aerospace, which are also developing their own supersonic jets. Geopolitical context. The introduction of the C949 is occurring amid rising tensions between the US and China, particularly regarding technological advancements. The competitive dynamics in aerospace not only reflect commercial interests but also implicate national security concerns. The dual-use nature of such technology, potential military applications, raises questions about the future of aerospace innovation and regulation. Market potential. The aviation industry is witnessing a renewed interest in supersonic travel, driven by technological advancements and changing consumer preferences. The capability of the C949 to operate on longer routes with reduced noise could position China favorably in global markets, potentially reshaping the landscape of international air travel. 3. Regulatory challenges and environmental considerations. While the C949 aims to mitigate sonic booms, regulatory challenges remain a critical concern. Environmental impact. The development of supersonic aircraft raises questions about their environmental footprint, including fuel consumption and emissions. The C949's design innovations may address some noise concerns, but the environmental impact of increased air traffic and supersonic speeds must be thoroughly evaluated. Navigating regulations. The success of the C949 will depend not only on technological advancements but also on its ability to comply with existing aviation regulations. if the jet can achieve the desired noise reductions. It may help pave the way for regulatory changes that could benefit the broader industry. 4. Future of supersonic travel and broader aerospace innovations. The C949 represents a pivotal moment in the revival of supersonic travel, but it also signals broader trends in aerospace innovation. Global supersonic renaissance. The renewed interest in supersonic travel suggests a shift in consumer expectations for speed and efficiency in air travel. This could lead to a new era of aircraft design focused on speed, comfort, and reduced environmental impact. Space air hybrid vehicles. COMAC's ambitions extend beyond supersonic jets to the development of space air hybrid vehicles. This indicates a potential convergence of air travel and space exploration technologies which could redefine transportation in the coming decades. In conclusion, the C949's development encapsulates a confluence of technological innovation, competitive dynamics, regulatory challenges, and environmental considerations. Analyzing these aspects will provide a comprehensive understanding of the future trajectory of aviation technology and its implications for global air travel. Here are 3 famous historical cases similar to the context of China's C949 supersonic jet development. 1. The Space Race 1957–1969. The space race was a competition between the United States and the Soviet Union during the Cold War, primarily focused on achievements in space exploration. It began with the Soviet Union's launch of Sputnik in 1957, the world's first artificial satellite. This event ignited fears in the U.S. regarding technological superiority and national security. In response, the U.S. accelerated its own space program, leading to milestones such as the Apollo 11 moon landing in 1969. The competition led to rapid advancements in technology and fostered a spirit of innovation that had lasting impacts on science and engineering. 2. The Concorde development 1960–2003. The Concorde was a turbojet-powered supersonic passenger airliner that was developed through a collaboration between British and French aerospace engineers. First flown in 1969, it was a symbol of cutting-edge technology and luxury travel, capable of cruising at twice the speed of sound. However, it faced challenges including high operational costs, limited routes due to noise restrictions, and safety concerns after a tragic crash in 2000. The Concorde's retirement in 2003 marked the end of an era in commercial supersonic travel, but it also laid the groundwork for future endeavors in this field. Similar to the current revival in supersonic aircraft development. 3. The jet engine development race 1950s. The 1950s saw intense competition among various nations and companies to develop more efficient and powerful jet engines for commercial aviation. Notable advancements included the introduction of the turbofan engine, which became the standard for modern jets. Companies like Rolls-Royce, Pratt & Whitney, and General Electric raced to innovate and improve engine performance, leading to the development of engines that were quieter and had better fuel efficiency. This competitive environment spurred innovation that significantly transformed commercial air travel, paralleling the current race to produce quieter and more efficient supersonic jets like the C949. These cases reflect broader themes of competition, innovation, and the interplay between technological advancement and regulatory challenges, much like the current landscape surrounding supersonic travel development. As China officially enters the supersonic passenger jet race with its ambitious C949 project, the global landscape of aviation is anticipated to undergo significant transformations. Here's a look at the future outlook for supersonic travel and its implications. 1. Technological advancements and innovations. The C949 aims to surpass the legacy of the Concorde by achieving speeds of Mach 1.6 and a range of 11,000 kilometers. These advancements are expected to spur further innovations in aerodynamics, materials science, and propulsion technologies across the aviation industry. Continuous developments in noise reduction technologies such as the C949's reverse-camber fuselage could set new industry standards, encouraging competitors to adopt similar or improved technologies. 2. increased competition and collaboration. With multiple players including U.S. companies like Boom Supersonic and Spike Aerospace entering the market, competition is likely to intensify. This rivalry could lead to accelerated technological developments as companies strive to outdo each other in speed, range, and passenger comfort. Additionally, partnerships between nations and companies may emerge, focusing on shared research and development costs, particularly in overcoming regulatory barriers related to noise and environmental concerns. 3. Regulatory challenges and environmental concerns. One of the significant hurdles for the revival of supersonic travel is the regulatory landscape, particularly concerning noise pollution. The C949's lower sonic boom levels present an opportunity to influence regulations and possibly allow for overland flights, which have been restricted in many countries. However, environmental concerns regarding fuel consumption and emissions will remain paramount. Future supersonic jets will likely need to focus on sustainable aviation fuels and innovative designs to minimize their carbon footprint, aligning with global climate goals. 4. Market demand and economic viability. The market demand for supersonic travel will heavily influence the success of these projects. There is a niche but growing market for ultra-fast travel, particularly among business travelers and affluent passengers. The competition to offer faster, quieter, and more efficient travel experiences could make supersonic flights economically viable in the near future. However, ticket pricing will need to be competitive with existing air travel options to attract a broader customer base. 5. Geopolitical implications. China's entry into the supersonic race raises geopolitical concerns, particularly regarding the dual-use nature of aviation technology, military and civilian applications. As nations invest in advanced aerospace technologies, the implications for national security will become more pronounced. This situation may prompt increased scrutiny and regulation of aerospace advancements globally, influencing how countries approach technological collaboration. 6. The future of air travel. The revival of supersonic travel signifies a shift in how people may perceive and experience air travel. The C949, along with its competitors, could redefine long-distance travel, making previously impractical routes feasible. As supersonic jets become operational, we may see a resurgence in intercontinental tourism and business travel, allowing for same-day return trips across the globe. 7. Emerging technologies in aerospace. Beyond conventional supersonic travel, emerging technologies such as hybrid airspace vehicles and potential space tourism applications are likely to gain traction. Companies like Mach are exploring these possibilities, which could lead to breakthroughs in both aviation and space travel. Conclusion. The entry of China into the supersonic jet market with the C949 is a critical moment in aviation history, marking the potential resurgence of a technology that has long been dormant. The coming years will be pivotal in shaping the future of air travel, with advancements in technology, evolving regulatory frameworks, and changing consumer demands driving the industry forward. As nations race to establish their dominance in this field, the implications will extend beyond aviation to touch upon environmental, economic, and geopolitical domains.